first thing I would do is just draw my triangle. Doesn't matter what it looks like, just as long as it's a triangle. After you draw the triangle, what I want you to do to the three sides is again mark where you think the midpoint will be. Just make a rough guess. Now, last week, actually it was a week ago today, when we had that 10-minute class period or 12-minute class period, we talked about the segments that connect midpoints. What are they called? Mid-segments? Those three mid-segments did not intersect each other. They created that fourth triangle, if you will, on the inside there. Okay? Just put away your phones. You can do it. Anyway, a median, and this is a new one, a median is the segment from vertex to midpoint across. The midpoint opposite. So with a triangle having three sides, a triangle having three midpoints, a triangle having three vertices, gee, I'm going to go out and take a guess. You'll probably be able to figure out how many medians a triangle might have. Okay, let's try this again. I know this is a difficult topic, but I'm sure I have faith in you. I knew he knew that too. I was just playing along. You okay? Just feel bad for him? Or me? It is pretty great. All right, anyway, so here's what happens. The median goes from the vertex to the midpoint across. And just like before, they also have what's called a point of concurrency. Remember we talked about that the other day? Where three things intersect. Where the medians intersect, it's called the centroid. 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 The centroid is where the three medians intersect. No, I'm just putting, you know how I have the other two up on the board? I'm just going to put one up here as well. So what I want to do that's the centroid. What I'm going to do real quick is I'm going to take one of these segments. Do you guys agree if you follow this? That's a vertex. That segment goes through the centroid and it hits the other side. You okay with that? It's not necessarily the middle. The centroid is where the three of them run into each other. We're going to explain what the centroid is here mathematically in a second. But what I like to do with this is I like to draw it as a segment. So we have vertex, centroid, and side. You okay with that? I'm just drawing that segment outside of the triangle right now. That whole thing is the median. This whole thing is what we call a median. Do you agree that the median is made up of two smaller segments? Think of it as just like segment addition. The whole thing is vertex to centroid, centroid to side. Those are the two segments. Is that okay? Now here's where the weirdness comes into play. 2/3 of the median, is the segment vertex to centroid. Okay. Which means how much is left for the other segment? 1/3. 1/3 the median is centroid side. Now, a lot of times people go, oh, what? Okay. Before we worry about anything, what's the relationship between 2/3, 1/3? Okay, they have a 3, right? What's that? Yeah, you put them together, it equals 1, okay. Well, how do you go from 1/3 to 2/3? What is it, Bill? Yeah, no, in other words, you double it. Isn't that right? So, isn't 2/3 double 1/3? Okay. Very good. Exactly. So even though this is where it comes in, it's just snow, guys. It's winter. It happens. What's that called? Yeah, you're gonna be all stuck here. We'll have to do math all night long. It'll be super exciting. That was awesome. What? That sounds awesome. Did you feel the eye roll on that one? Anyway, back to this. That's relationship between 2/3 and 1/3. If you double 1/3 with two of them together, you get 2/3. That's all it means. Okay. So if you go through all of it, you get some different scenarios. Let me write these out. We know that 2/3. Remember I say the word of in math usually means multiplying? 2/3 of something. Not O, of. I'm just going to use med for medium or median. Paul, you said this a second ago. What's the relationship between vertex and centroid to side? Perfect. Yep. What happens here, guys, is you get 4 different scenarios. Depending upon what information you have in the picture, you use one. So we know that 2/3 the whole thing is vertex to centroid, 1/3 the whole thing, centroid to side, which means if you take half of vertex to centroid, it'll equal centroid to side. If you double centroid to side, it equals vertex to centroid. Those are the scenarios that we're looking at. Okay. Okay. It's really straightforward. What's that? Yeah, but as you start looking at it, as long as you know what part you're working with, it's super easy. Because more often than not, the number's going to be clean. Okay? More often than not, your number's going to be clean. For example, if I go back to the just split this real quick. If I go back to the picture here, and then let's maybe just blow this one up a little bit. Get this stuff out. And I say that this much is 12. How much is that? 6. Vertex to centroid is half. I'm sorry. Take half of the vertex to the centroid, you get centroid side. What's half of 12? 6. Right. So if this is 12, this part would be 24. Yeah, depends on what you know. If this whole thing, that whole thing is 45. What's a third of, very good. What's a third of 45? When you take a third of something, it's just divided by 3. What's a third of 45 then? 15. That makes one side 15, the other side 30. It's a lot of words for something that is stupid easy. You're not buying it. But you're staring at it like you're not buying it. Okay? It's knowing what you're working with. And a lot of times as you get into the diagram, it's pretty easy to tell. Okay? Pretty easy to tell. Because this part will always be longer than that part. Okay. Again, if that's 8, what's on the other side of it? 4, which makes the whole thing 12. Vertex to centroid is 8, which means centroid to side is 4, which means the whole thing is 12. Getting there? Don't worry about all those fractions. It's very, it should be pretty easy. Okay. Now, in this one, this should say RW is 12. Take a second. Draw this one up. Remember what medians are running into. I'm sorry. So as you get into this, okay. As you get going into this, what you want to look at is just the picture. You gotta look at the picture. Remember what medians are connecting. Medians connect midpoints. Okay. So if you're connecting midpoints, you'll know what the outer segments might be. So you know that RW is 6. That makes RV how? I'm sorry, RW is 12. What that makes RV how much? That's easy. Okay, 6. RS is that vertex to centroid or centroid to side or the whole thing? The whole thing. You're right, it's not the whole thing. Which part is it? Vertex to centroid. So vertex to centroid is 4. How much is centroid to side? 2, which means the whole thing is 6. Okay. TV
Is that the whole thing or a part of it? So if the whole thing is 9, what's the easier one to find? The centroid to side or vertex to centroid? True, but which one is easier mentally? Correct. Centroid to side. When you're given the whole thing, it's always easier to find the centroid to side first because you're taking 1/3 of something. A third of something is the exact same thing as divided by 3. What's 9 divided by 3? 3. So if centroid to side is 3, what's the other side? 6. Just double it. Because the whole thing has to add up to equal 9. If you took away 3, how much is left? 6. So remember, it's not that we have to math very hard here. It's just have to remember what you're looking at. That's all you have in here that you can find. We don't know how to do angles yet. We will. We'll be able to figure out that angle here eventually. Well, let me move this diagram around here a little bit bigger for you. Take a minute to do that one. No! We get to do algebra. It's great. It is. Your friends are sticking up for you. Anyway, algebra. When you get to the algebra now, it's okay. You have to trust it. You have to trust it. Now, we're looking at CG and CE. Everybody okay with that? That's this segment. Vertex, centroid, side. All I'm doing is labeling. Okay? Because you can do segment addition, can't you? All right. This part, CG, is 3x plus 7. The whole thing is 6x. What parts do you know? You know vertex, the centroid, and you know the whole thing. Which of those 4 do you use? And it's the first one. 2/3 of the whole thing is vertex to centroid. 2/3 the whole thing. This is your setup. 2/3 the whole thing, the median, is vertex to centroid. Fill in the blanks. 2/3 of 6x is 3x plus 7. When you use your calculator, but think of it easily. What's 1/3 of 6? What's 6 divided by 3? 2. Double it. 4. So 2/3 of 6 is 4. Okay? So 4x equals 3x plus 7. What's x? No, it's not 0. Which is it? No, I thought you were about 6. I mean 7. See how quick that is?
It's just remembering which one you're working with. So you can fill it out. Okay. And that's the trick. Once you start going into that, you're okay. If you remember this is always the longer segment. This is the shorter. So I gotta remember. Oh, you're trying to take half of this and then add it to that to put it the other? It would have gotten there. Yeah, it would have been awful, but it would have worked. Absolutely, that would have worked. Because half of 3x plus 7 would be 1.5 plus 3.5, so it'd be 4.5 plus 10.5 equals 6x. Subtract it over, you get 10.5 is what, 1.5? Is that about right? So that's what, 10, that's 20 over 2 is 3/2 x. No, that didn't, I did something incorrect there. Not 20 over 2, it's 21 over 2, which is 7. Yeah, it works. Yeah, absolutely. That would work just fine. You would have. If you, no, you would have. What he was doing, guys, what Billy was doing there, you can do it if you wanted to go that route. We had the whole thing, but he remembered that if you took half of the vertex to centroid, it equals centroid to side. So he thought 1/2 of 3x plus 7. And then he added that to the original. It's just ugly. It works. It's just ugly. That's why we have the other side. You would have gotten there. I mean, if you're using the calculator, you would have been. Would have been. All right, let's try another one. Same diagram, same picture. Let's look at that one. So don't look at this one anymore. I'm sorry, what's that? Oh. 6. Again, let's try the same thing with same diagram, just a different segment in there. So we have FG is the x plus 8. AF is the 9x minus 6. So in this one we draw it out. We have centroid to side, and we have the whole thing. It's not a bad idea. It's not a bad idea just to draw like a segment like that, because then you know exactly which parts you're looking at. It's just a little bit, it's cleaner unless you just want to label it. I'm not going to tell you one way is better than another. I like to draw it because I'm very visual when it comes to this kind of stuff. Because now I know that the centroid to side is 1/3 of the whole thing is that centroid to side. So I know that 1/3 of 9x minus 6 is x plus 8. What's 1/3 of 9? What's 1/3 of 6? 2. Write some other stuff here. So we get 3x minus 2 is x plus 8. So quick move around. Yeah. I didn't label it. Vertex, centroid, side. Yeah. Yep. Subtract x, add 2. 2x is 10. I had 6 of these for you. It's already posted on the calendar. I said I have 6 of these. It's called Q-tip. Yeah, you're.